Assalamu alaikum everyone. Sir, my name is what's that? Adan. All right. Hello, Adan. Sir, I'm an O-level student. In 11, got notified about your stream. Okay, so this stream sadly is not going to be very helpful for you. You can watch it next year. Sir, my coaching teacher finished both V1 and 5. Okay, that's interesting. Started in July. Okay. M1 and P1. All right, that's interesting. July, August, September, October, November, December doesn't count. July, August, September. 5 months. Okay. Thank you. Sir, इसी के लिए इंतज़ार कर रहा था. हाँ, I know. Trigonometry, functions, these are two topics I get the most requests for. So, trigonometry की topical playlist is on its way. And you will have the concepts, inshallah, in no time. In this stream, however, I'm just going to solve past paper questions. Will this stream be saved? Yeah, this stream will be saved. So, don't worry. We had 6 classes in a week. All right. Then it makes sense. Okay, 6 classes in a week. So, don't you have other subjects as well? Khair, as long as long as it's been taught well, then it doesn't matter how long it takes. Anyway, so let's wait for a couple more minutes and then let's start. Sir, I'm preparing AS level. I need math complete concept coverages. Kindly provide me organized video package. Kindly do the needful. Okay, so just go on the AS section. Okay, go on the AS section on my channel, and then there you will find all the topics. Okay, so far I have a lot of videos of trigonometry, functions, binomial, APGP. So there's a separate playlist for live streams of AS. Okay, you can check that out. Trig, inshallah, coming week. So I have made all the videos. I just need to upload them one by one. Part 6, inshallah, will be out, I think, tomorrow. And then, yeah, coming week, inshallah, it'll be complete. Do you plan on doing stats? Yeah, I'll be doing stats and M1 also. Yeah, I'll do, don't worry about it. I'll do S1 and M1. So you'll have all of S1 and M1, inshallah, before the end of exams. I mean, before your exams. ठीक है, not before the end, but yeah, before your exams, inshallah, you'll have S1 as well as M1. ठीक है. Coordinate geometry. Coordinate geometry. I've done a lot of past paper streams of coordinate geometry. Yeah, I have, and I've done equation of circles as well. Because in coordinate geometry, you don't really have new concepts. It's the same as O levels. It's just that the questions are complicated. ठीक है. Anyway, so M1 kinematics is kidding. Okay, that's fine. Don't worry about it. So I'm going to start now. Let's see what we have. Thank you, sir. Noted. I'd like to know which book are you using for AS level math. Okay, the book that I'm using is... Just a minute. I'll tell you the book that I'm using. So it's by Sue Pemberton. Okay, the name of the author is Sue Pemberton. Do you still teach in NNGC? What is that? NNGC? I used to teach at Nixer, but not anymore. Do you recommend M1 or S2? That's a topic for a different video. Okay? So we'll come to that later. Need help in limits and accuracy. So that's O levels. That's O levels in IGCSE. This is A level trigonometry. So O level students, please don't watch this. Anyway, so I would really appreciate before we start if you guys like this video. That would mean a lot. So yeah, let's start. Okay, so as always with every past paper question, what I like to do is I like to sort of look at the questions first and highlight the difficulty level. Okay? So I've done just that in here as well. So the ones that you find green are easy, the ones that you find yellow are medium, hard, and then insanely difficult. Okay, now let me tell you something about trigonometry. Trigonometry generally is a difficult topic. Okay, generally you'll find trigonometry to be a challenging topic. So yeah. So we're gonna solve some questions. We're gonna start with some easy ones, and then we're going to gradually increase the difficulty level. So there are three main concepts in trigonometry. Okay, you have graphs, you have equations, and you have identities. Okay, you can expect one question to cover at least two of the concepts. Okay, so one question is very likely to cover at least two concepts. So like I said, we're going to start off with some easier ones. So here's a question. It's a past paper question. It's October November 2021, paper 11. Okay, I don't teach anywhere, Nimra. I just teach online. Okay. Okay, so I'm going to solve this question now. Pay close attention. So this question says, solve by factorizing the equation. Okay, so what do we have to do? We have to solve this by factorizing the equation. So the first thing you should do with a question like this is that you should always, especially when you're solving identities, is that you should always turn everything in terms of sine and cos. Yes, Ikra, this stream is for AS trigonometry. Okay? Just a minute. Okay, yeah. So here's what we're going to do. Like I said, we're going to turn everything into sine and cos, and then we'll see where we stand. Okay? So let's see what we can do over here. Is there anything that I can take common here? First, let's see if we can take something common, okay? Then we'll see if we have to convert it into sine and cos. Because it says solve by factorizing, that means we can maybe do it by taking something common. So here, if you look closely, you can take 3 cos theta common, okay? This is October, November 2021, paper 11, okay? You will find a PDF of this and a PDF of the notes in the description, okay? So if I take 3 along with cos common, so that means this is what we're looking at. We're looking at 2 tan theta minus 1, okay? And here I can take 2 common, okay? Whatever it is that I should take common, in the bracket I should have 2 tan theta minus 1. So what should I take common so that in the bracket I have 2 tan theta minus 1? The answer is 2. So we have 2 tan theta minus 1 equals to 0, okay? So next thing you want to do is 3 cos theta plus 2 into 2 tan theta minus 1 equal to 0, okay? So what does that mean? That means 3 cos theta plus 2 equals to 0, or 2 tan theta minus 1 equals to 0. Solve this further. So you will have cos theta is equals to minus 2 upon 3. Okay. And then solve this further. So you'll have tan theta is equals to 1 upon 2. Now look at the range of theta. The range is from 0 to 180. Okay. So let's solve one by one. Achha, I'm going to color code it to make it easy. This I'll turn green. So cos is negative. Where do we find cos to be negative? So cos is negative in the second and the third quadrant. Okay, so cos is negative in the second and the third quadrant. And one thing we should do immediately is that we should find alpha by taking cos inverse of 2 upon 3. So alpha is equals to, let's see, cos inverse of 2 divided by 3. Make sure that your calculator is in degree mode, not in radian mode. So we're looking at 48.2. Okay. And here also might as well find alpha while we're at it. We can find alpha by taking tan inverse of 1 upon 2. So we're looking at 26.6 degrees. Okay? Achha. So cos is negative, like I said. And where do we find that? We find that in the second and the third quadrant. Okay? So here we go. And here we go. Now, although it's the second and the third quadrant, but our range only allows us to go up until the second quadrant. Why? Because it's from 0 to 180. So the only angle that we're going to count is this angle. So what is this angle going to be? It's going to be 180 minus 48.2. Let's see, what do we get? 180 minus 48.2. So we have 131.8. So one value of theta is 131.8 degrees. Let's find the other value. How are we going to find out the other value? Tan. The other value is going to be 26.6 only because tan is positive. And where is tan positive? It's positive in the first and the third quadrant. Okay. Now, for the same reason, We can't go in the third quadrant because it's from 0 to 180 only. So what is the value of theta going to be? It's going to be 26.6. Okay, so that's it. Like I said, this is a fairly easy question. That's your answer. 4 easy marks. Considering how difficult trigonometry questions can be, I would say these are 4 easy marks. So let's move on to the next question. Thoughts about this question? What do you say? Easy, medium, difficult? O-level trigonometry. So I will be streaming more frequently, inshallah. So I've done one for AS level, then I'll do another for O-level maths or at maths. Okay? So stay tuned. Okay, so that was a fairly easy question. Yeah, like I said, fairly easy question. Let's do another easy question before we do some difficult questions. Okay. All right, let's do this. So prove the identity. Now identity questions are my favorite. Why? Because yes, all this sheet contains trigonometry questions. Okay. Sir, why don't you promote your website? I'm not working for Bright anymore. It's fact, it's been a long time since I stopped. Here, this is May June 2020 paper 11. So a recent question. All right, let's see. So in the denominator, here's what we have. We have cos theta into 1 plus sine theta. Okay, this is what we're going to get once we take LCM. So what are we going to multiply 1 plus sine theta with? We're going to multiply it by 1 plus sine theta. That means we're looking at 1 plus sine theta, the whole thing square. Now keep your eyes on the price. We're supposed to bring it equal to 2 upon cos theta, whatever it is that we may have to do. Okay. Then what we're going to do is we're going to multiply cos theta with cos theta. That means we're looking at cos square theta. Okay, no need to write whatever it's identical to. Okay, next thing we're going to do is we're going to expand. So we have 1, remember to use the identity, the algebraic identity to expand this. 1 plus 2 sine theta plus sine square theta plus cos square theta over cos theta into 1 plus sine theta. Okay, now sine square theta plus cos square theta, what is that going to be equal to? That's going to be equal to 1, and then 1 plus 1 is going to be equal to 2. Okay, so I'm going to skip a few steps here. This is 1, and here we have 1, so 1 plus 1 is 2. So that means 2 plus 2 sine theta over cos theta into 1 plus sine theta. All right. What can I take common in the numerator? I can take 2 common. So we have 1 plus sine theta. What about the denominator? In the denominator, we have cos theta as it is, multiplied by 1 plus sine theta. What happens next is that 1 plus sine theta and 1 plus sine theta cancel each other, and we're left with 2 upon cos theta. So there you go. That's your answer. Now, thoughts. As always, what are your thoughts about this question? Yeah, this is easy. Yep, this is easy. So we are starting with easy questions, okay? I don't want to immediately jump to difficult questions because then you guys will probably freak out. Okay? Okay, so here we have another question. It says, hence solve the equation. So this is just a continuation, and I think this is also fairly easy, so let me just highlight it. But here, remember to convert your calculator into radian mode. Okay, something you should do immediately. So now that we know that all this is equal to 2 upon cos theta, so we're simply going to replace it with 2 upon cos theta. So 2 upon cos theta is equals to 3 upon sine theta. And you can probably see where this is going. Cross multiply. In fact, just swap places of 2 and sine theta. So we get sine theta upon cos theta is equal to 3 upon 2. Which means tan theta is equals to 3 upon 2. And tan is positive. Where do we see that? Where do we see tan is positive? Tan is positive in the first and the third quadrant. Okay. So this is 0. This is pi upon 2. Remember, your calculator should be in radian mode. I do not suggest that you first find the answer in degree mode and then convert it to radian. Not at all recommended. Okay. So how do we know we are not supposed to multiply brackets? What do you mean? How do we know we're not supposed to multiply brackets? What do you know? What do you mean by that? Can you elaborate? Okay. So alpha, let's find out what alpha is going to be by taking, first of all, converting calculator into radian mode. So I'm going to do just that. Radian. Tan inverse of 3 upon 2. So we're looking at 0.983. Add math stream inshallah soon. Okay. No point in spamming. Not going to change my mind. But yeah, I'll do it soon inshallah. Don't worry. Okay. So 0.983 and 0.983. Okay. So first quadrant, what is it going to be equal to? It's going to be equal to 0.983. And then the third quadrant. How do we find it out in the third quadrant? In the third quadrant, we do pi plus alpha. Okay. So do that. Let's do pi plus alpha. See what do we get. Pi plus, and use the answer key. Okay. So we're looking at 4.12. So 4.12 is your answer. So how do you know? Okay. So if let's say you do multiply the denominators in the brackets in the denominator, and then later on realize that you weren't supposed to do that, so that's okay. Just change it back. Okay. So you can't start a question by knowing exactly what you need to do. So which is why you solve as you go along, and then later on if you realize that this is not what we were supposed to do, so you just bring it back in its original form. Okay, no rocket science. And this, by the way, I don't know if I mentioned, is from May June 2020, paper 11. Okay. Sir, how many questions have we done yet? Also, how long is the stream? So we have done how many questions have we done? I think this was the second question. And the stream is going to be 2 hours at max. Okay. So let's I think let's increase the difficulty level, shall we? Yeah, let's increase the difficulty level. Let's solve this. Okay. So this is a question from February-March 2020, paper 12. Okay. February-March 2020, paper 12. It's a 5-mark question. That means a lot of working involved. Okay. So let's see. Solve the equation. So this is not an identity. We might have to use the identity, okay, to solve this, but at the moment it's an equation. Okay. So first thing you want to do is you want to cross multiply, of course. So what we're looking at is we're looking at tan theta plus 3 sine theta plus 2. All right. And what is this equal to? This is equal to 2 tan theta minus 6 sine theta plus 2. Okay. There you go. All right. Now we have plus 2 on both sides, so we can cross that out. All right. And then let's get all the terms on the left hand side. So this is what we end up with. We have tan theta minus 2 tan theta plus 3 sine theta plus 6 sine theta equals to 0. Okay. So tan theta minus 2 tan theta is going to be minus tan theta. All right. And then you have plus 9 sine theta, which is equal to 0. Okay. Now, let's see what we can do next. Let's rewrite. In fact, first let's write this nicely. So we have 9 sine theta minus tan theta. Yeah, this is much nicer. Okay. Sir, can you tell why did you convert in radian mode? So that's because the range that was given to us was in radian. Okay, Samina, the range that was given to us was in radian. And that's why we converted it to radian. Okay, that's going to be our, like for example, here, the range that's given to us is degree. So that means when we solve this equation, we're going to give an answer in degree. Okay, so if your calculator is in radian mode, you should convert it back to degree mode. Okay, that is what you will see and decide whether you have to convert it into radian or degree. Okay. All right, so what's tan theta going to be equal to? Tan theta is going to be equal to sine theta upon cos theta equal to 0. So we're going to take the LCM, which is going to be cos theta. All right, when you take the LCM, here's what you're looking at. 9. So this gets multiplied by cos theta. That means 9 sine theta cos theta minus sine theta equals to 0. Okay, so cross multiply, cos theta gets multiplied by 0, and this is what we're looking at. 9 sine theta cos theta minus sine theta equals to 0. Okay, what do we do next? Something we can take common? Yes, we can take sine theta common, and if you take sine theta common, what do you have? You have 9 cos theta minus 1 equals to 0. That means sine theta is equals to 0, or 9 cos theta minus 1 equals to 0, which if you solve, you have cos theta is equals to 1 upon 9. And since it's positive and the range is only from 0 to 90, we can immediately find out the value of theta by simply taking cos inverse of 1 upon 9. No need to make the 4 quadrants here, okay, because you don't have that much range. In fact, you only have the first quadrant. So where did cos come from? All right, let me answer that. Cos inverse of 1 upon 9. So we're looking at 83.6. Let me see if that's the correct answer. Yeah, 83.6. Acha, where did cos come from? So we changed tan to sine theta upon cos theta. Okay, so that's how we got cos. Okay, so we have one answer. Now sine theta equals to 0. When is sine theta equal to 0? These are special values. Okay, 0, 1 and minus 1. Your calculator is not going to be of much help here. So for this, you need to recall the shape of the curve. So if you recall the shape of the curve, this is what it looks like. So wasn't it supposed to be plus tan theta? Yeah, it was plus tan. No, actually it's minus tan theta. Because tan theta minus 2 tan theta turned out to be minus tan theta. Okay. So this is the shape of sine. And when exactly is it equal to 0? Like I said, your calculator is not going to be of much help over here. It's equal to 0 at 0, 180 and 360. Okay, so which value do we have here that's inside our range? Let's have a look at the range. Range is from 0 to 90. That means we just have 0. And let's see if 0 is included. Yes. So since 0 is included, our final answer of theta is going to be 0 and 83.6. 0 degrees and 83.6 degrees. Okay, there you go. Take a good look at it. And let me know what your thoughts are. अभी तक तो वैसे सारे आसान questions हम कर रहे हैं solve. Even though I said, can you explain the shape part? What shape part? Okay, Zara, you can always rewind the video. Acha, but I'll explain anyway. So basically, this is the graph of sine. Okay. How is 0 an answer? So sine theta equals to 0. This is the equation that we need to solve. Okay, so when is sine theta equal to 0? Find out by taking sine inverse of 0. Or if, let's say, now see, the thing is here, if you take sine inverse of 0, you get 0 as an answer. So you might think, why do we have to draw the shape of the curve? Okay, and in this case, you're right. But the thing is, what if the range was from 0 to 360? So what if I ask you, this is a separate question, okay? Question for you guys. See if you can answer it. Let's say you're given sine theta equals to 0, and the range of theta is from 0 to 360. Okay, 0 is included and 360 is included. Can you tell me what the answer of theta is going to be? See if you can do that while I find some other question to solve. Sir, Vikas Khan kaise teacher hain? I don't know, beta. I have no idea. And besides, the best answer you're going to get is probably from a former student. Sir, can you do... I did a stream on APGP. Yeah, I did a stream recently on... Yeah, we would have made the grid, exactly. So because our calculator doesn't really know exactly what we're trying to do. So if you take sine inverse of 0, your calculator just gives you 0. Okay. So the question is sine theta equal to 0 only at 0? No. It's equal to 0 at 0, at 180, and at 360. Okay. So in cases like these, don't use your calculator. Use the graph. Okay. And what are the cases where you're going to use the graph? 0, 1, and minus 1. Okay. So for example, if tan theta equals to 0, where does that happen? That happens at 0, 180, and 360. So if you try and use your calculator to find out tan inverse of 0, you do get an answer. You do get an answer, tan inverse of 0, but that's just 0. Okay. Okay, let's do another question. Should we do a difficult question now? Okay, now this question is, we'll do this question later. We will, but we'll do it later. Let me, okay, let's solve this question. Why not 90? Tan inverse, why not 90 to what? When is tan inverse of 0 is not 90, because tan at 90 is infinity. Okay, I'm not sure what is that counter question to, like what exactly do you mean by why not 90, like why not 90 what? So if you can elaborate, I'll be able to answer that question. Okay. Anyway, I'm solving another question. This, by the way, is the very first question of this worksheet. Sir, can you do trigonometric graph questions? All right. Let's see if I have trigonometric graph questions here. I think I do. Yeah, I do. Here is one. So, okay. Stream on differentiation. I think I did a stream on differentiation. I'm not too sure. So there is a playlist which has all my streams for this year. Okay. So you can check it out. Sir, do you do online classes on Zoom? Okay, if you're talking about AS, then you can't join now because it's too late. I'm almost done with P1. There will, however, be a past paper crash course later this coming year, which means January, February. To the question, sine x equals to 0. So, is the graph of sine equal to 0 at 90? No, it's not. It's equal to 1 at 90. Okay, so sine 90 is equal to 1. Sine 0, sine 180, and sine 360 is equal to 0. Okay, I'm using PDF Expert. Anyway, let's do this question. This is a tricky one because it has multiple concepts here. It says, given that k is equals to 3, find the exact solutions. Okay, exact solutions means that once we have our solution, we should leave it in surd form or in terms of pi. In terms of pi, if we have the angles as well. Okay, but here, no. Yeah, in surd form or in terms of pi. Okay. So k is equals to 3. 4 cos power 4x plus cos square x minus 3 equal to 0. Okay. So this has a quadratic equation hidden in it. So you can treat it like a disguised quadratic equation question, or you can solve it like as it is. Okay. So let's see. For cos square x, let's call this equal to a. Okay. Cos square x is equal to a. So that means we have 4a square plus a minus 3 equals to 0. Okay. Now let's solve this through middle term breaking. So we have 4a square plus 4a minus 3a minus 3 equal to 0. All right. So let's take 4a common. So we have a plus 1. Let's take minus 3 common. So we have a plus 1 again equals to 0. Can we take the 4 as a? What do you mean? Can we take the 4 as a? Not sure if I understand that. So 4a minus 3 into a plus 1 equals to 0. Okay, don't forget that you made a substitution. Let's find out the value of a first. So a is equals to 3 upon 4 or a is equals to minus 1. Now don't forget that this is not the end of the question because you made a substitution earlier, which means cos square x is equals to 3 upon 4 or cos square x equals to minus 1. This of course is not possible because when you try to take the square root of minus 1, you get an error. Okay. Cos square x equals to 3 upon 4, however, is something that is possible. Okay. So what do? We say cos x is equals to plus minus. So we take the square root on both sides. Plus minus under root 3 upon 2. Why? Because root 3 will remain as it is since 3 is not a perfect square. Root 4 is equals to 2. So it's going to be under root 3 upon 2. Okay. Now, what will happen because of the plus and minus? That means we are solving two equations. Okay. What are the equations that we are solving now? The two equations that we're solving are cos x is equals to positive under root 3 upon 2 or cos x is equals to minus under root, sorry, not alpha. Cos x is equals to minus under root 3 upon 2. Okay. Since they're both the same, that means we can find out alpha by taking cos inverse of under root 3 upon 2. Let's see what that is. Cos inverse of under root 3 upon 2. So what is that equal to? Let's see. That's equal to 30. Okay. I just realized my calculator is in degree mode. And if you go back, the range is in for terms of pi, that means we have to solve this equation in radian mode. Okay. What are surds? Surds are like square root 2, square root 3, square root 5. These are surds. Okay. All right. So cos inverse, just a minute. Yeah. Cos inverse of under root 3 upon 2 is 1 upon 6 pi. Okay. Now, because cos is positive as well as negative, that means we have this angle in all 4 quadrants. Okay. That means we have this angle in all 4 quadrants. Okay. So here we have 0, here we have pi upon 2, here we have pi, here we have 3 upon 2 pi, and here we have 2 pi. So 1 upon 6 pi, 1 upon 6 pi, 1 upon 6 pi, 1 upon 6 pi. Okay. Now one by one, let's find out the value of theta, or x in this case. So x equals to 1 upon 6 pi, and then x is equals to pi minus 1 upon 6 pi, which means it's going to be equal to 5 upon 6 pi. And then x is equals to pi plus 1 upon 6 pi, that means it's going to be 7 upon 6 pi. And then 2 pi minus 1 upon 6 pi. Okay, I better use a calculator for this. So just do 2 minus 1 upon 6, and then you can write pi later. So 2 minus 1 upon 6 is 11 upon 6 pi. There you go. Okay, so these 4 are your answers to the value of x. There you go. I hate trigonometry. Okay, thank you. All right, so this was a pretty challenging question, and as always, let's hear your thoughts. Okay, we're not done with this. We still have to do part B. But yeah, still, I'd like to hear your thoughts. Okay, part B. Now, part B is a very tricky question. Okay, let's see what it says. So, part B says, use the quadratic formula to show that when k is greater than 5, this equation f of x equals to 0 has no solutions. Okay, so what does the quadratic equation look like? This is what it looks like. It looks like 4 cos power 4x, 4 plus cos square x, plus cos square x, minus k equals to 0. Okay, so what's the variable over here? The variable over here is actually cos square x. Okay, so that means, you know how we write down the quadratic formula? We're solving for x. Here, when we write down the quadratic formula, when we use the quadratic formula, what we're solving for is actually cos square x. Okay, so that means cos square x equals to minus b, which means minus 1, plus minus b square, which means 1 square, minus 4 into a into c upon 2a, which means 2 into 4. Okay, now bear in mind that the coefficient of cos square x are the values of a, b, and c. Is the value of a. Coefficient of cos square x is the value of b, and coefficient of cos power 4x is the value of a. Okay. Does add math O level cover most of P1? Yeah, it does actually. It does. Okay, it gives you a very strong edge. All right, so cos square x equals to minus 1 plus minus square root of 1 minus 16k upon 8. Okay. Sorry, not minus actually, it's going to be plus because c is negative k. Yeah, so it's going to be plus. Okay. Okay, so what does the question say here? The question says, show that when k is greater than 5, the equation f of x equals to 0 has no solution. Okay. So what if k is equal to 5? Let's see what happens if k is equal to 5. Okay, so we're just making an assumption here that let k equal to 5 just so that we can see what happens. Okay. So if k is equals to 5, cos square x equals to minus 1 plus minus square root of 1 plus 16 into 5 upon 8. So that means cos square x is equals to minus 1 plus minus 16 into 5 is 80. 80 plus 1 is 9. 80 plus 1 is 81. Square root of which is 9 upon 8. Okay. Now if you solve this, here's what you get. You get minus 1 plus 9 upon 8. Okay. And you get cos square x to be equal to minus 1 minus 9 upon 8. Okay. Now, the interesting part is that this is not possible. Okay, this is not possible. So, here what do we get? Here what we get is we get cos square x to be equal to 1. Okay, this though not possible. Not possible. Okay. And this happens when k is equal to 5. Okay. So if k is equals to 5 and if k equals to 5 leads to, when k is equals to 5 leads to cos square x being equal to 1, what will happen when k is greater than 5? When k is greater than 5, that will lead to cos square x being greater than 1. Okay. And what happens when cos square x is greater than 1? So consequently, cos x will also be greater than 1. And what happens when cos x is greater than 1? When cos x is greater than 1, that is not possible. Why? That's because cos x is in between minus 1 and 1. Okay, and you can try it out. Take k to be equal to, let's say, 6. So 16 into 6, let's work that out. 16 into 6 is 96, plus 1 is 97, square root of which is 9.84. So minus 1 plus 9.84, what is that equal to? That's equal to 8.84. Divide by 8, so you get 1.106. Now if cos square x is equals to 1.106, what happens when you take the square root of a value that is already greater than 1? If you take a square root of a value that's already greater than 1, you get a number that's also greater than 1. Okay? And what happens when a function like cos x or sin x is equal to a number that's greater than 1? It's not possible. Why is that? That's because if you focus on the graph of cos x, it's revolving between 1 and minus 1. Okay, it doesn't go beyond 1 and it doesn't go below minus 1. Okay, so take a good look at it and let me know what your thoughts are, because this was a challenging question. Sorry about that. You think this question qualifies as an insanely difficult question, or you would say this is a fairly easy question? Walaikum salam, Abdul Hakim. Sir, is there only one way? Yeah, there's no other way. You have to first see what happens when k is equal to 5, and then you have to show what happens when k is greater than 5. Okay? Because we can't use the concept of discriminant here. This is a trigonometric equation. We can't use the concept of discriminant here. Sir, is this range thing which you did for cos x, is it for every? No, it's only for cos x and sin x. Okay, for tan x could be equal to anything and you will be able to solve it. Why is that? Okay, don't memorize stuff like, don't memorize these things. Focus on the concept. If you look at the graph of cos x, you will notice that it's in between 1 and minus 1. So what if I say cos x is equal to, let's say 5? Is it possible for you to solve? Of course not. Okay, like for example, if let's say I say 2 to the power x equals to minus 4. Can you solve this? Of course you can't. Why? Because 2 power x is never equal to minus 4. Okay, so just like that, if let's say cos x is equals to 1.1, again, not possible. Why? Because like I said, look at the graph of cos x. It's in between 1 and minus 1. Camera's a bit laggy, really? For everyone or just for you? Let me know if it is, because if it is, then I'll change the setting for next time. O-level functions. Are you talking about O-level math functions? Or are you talking about O-level add math functions? Yeah, range of cos x between minus 1 and 1 inclusive. Exactly. So if cos x is greater than 1, it's not possible. O-level पे कर लेंगे इंशाल्लाह, don't worry. Okay, let's do a couple more questions. Let me find some good questions. Yeah, FPS is on 60 frames per second. Okay, let's solve this, the negative range one. Okay, and then we'll do a question where we have to alter the range. Okay, so solve the equation 2 cos theta minus equals to 7 minus 3 cos theta. Okay, so we'll start by taking the LCM. I'm unable to understand the tan graph. So check out the trigonometry playlist. Okay, in that I have a video where I've discussed the 3 trigonometric graphs. Okay, so you'll find the graph of sine, cos, and tan. Okay. Okay, so 2 cos theta equals to 7. In fact, wait a minute. Let's take the LCM on the right hand side, which is going to be cos theta. That means we're looking at 7 cos theta because we're going to have to multiply it by cos theta minus 3. Okay, LCM part, I hope everyone knows how we're going to work this out. Or you could do that, or you could multiply everything by cos theta throughout. Okay, that's another way of looking at it. So 2 cos square theta when you cross multiply equals to 7 cos theta minus 3. That means 2 cos square theta minus 7 cos theta. No, we haven't done these in the playlist of trigonometry. I've only uploaded 5 parts. Part 6 may be out tonight. And then this week, inshallah, you will have all the parts. Okay? Minus 7 cos theta plus 3 equals to 0. Okay? So let's solve this guy's quadratic equation. You can make a substitution or you can do it without the substitution. That's fine. So 2 cos square theta minus 6 cos theta minus cos theta plus 3. I expect you guys to know how to solve a quadratic equation. So what do we have? Let's take cos theta common. So we have 2 cos theta minus 3. Okay, I think I made an error. Okay, we were supposed to take 2 cos theta common. So that way we will have cos theta minus 3. Okay. So that way we will have cos theta minus 3. Okay, then we're going to take minus 1 common, which will leave 2 cos theta minus 3 inside the bracket. Okay. How'd you get cos square theta? Okay, what do you think we'll do from this step onwards? We'll cross multiply, right? So that's how we got cos square theta. So we have 2 cos theta minus 1 into cos theta minus 3 equals to 0, which leads to the conclusion that cos theta equals to 1 upon 2 or cos theta equals to 3. Now this of course is not possible. This of course is not possible. Okay. This however is possible. Now here's something interesting. The range for this question is minus 90 to 90. Okay. That means if you're starting from 0, we're only going to the first quadrant, okay, which is positive 90. And then in the clockwise direction, we're going to the fourth quadrant. Okay. Yeah, cos theta equals to 3 is not possible. It's undefined. Okay. So first of all, make sure your calculator is back in degree mode. Okay. So let's find out alpha, for which we will take cos inverse of 1 upon 2. And by the way, cos is positive. That means it's in the first and the fourth quadrant. Okay. So cos inverse of 1 upon 2 is equal to 60 degrees. So that means here we have 60 and here also we have 60. 60, 60. Okay. So in the first quadrant, things are pretty straightforward. We can find out theta by going in an anti-clockwise direction. It's going to be 60 degrees. But what about this? What about this? How will I work out the other angle? Is this what I'm going to do? Am I going to do 360 minus 60 or what? Question for you guys. क्या हो गया भाई क्या लड़ाई हो रही है यहाँ पे hello sir, you saved my ad mass. All right, thank you. Okay. All right, hello, knowledge. Minus 60. Okay, why is that? That is because we will go in a clockwise direction. Okay, now let's say, now there are two ways to go about it. Okay, one is that you can do it through the quadrant. All right, now if you have the quadrant in front of you, your life is going to be a whole lot easier because you would know exactly what you need to do. Okay, so you can see that the quadrant allows us to go on the negative side, which we're going to go in a clockwise direction. And if you're going in a clockwise direction, that means the angle is going to be 60 degrees, but it's going to be minus. So theta is equals to minus 60 degrees and 60 degrees. Okay. Okay. All right. Acha. Here's the thing. The other way to do it is that you find out the first two solutions, okay, 60 and 300 minus 60, which is equal to 300. Now, because your range allows you to go on the negative side, what you're going to do is you're going to subtract 360 from both these answers, and whichever one falls inside the range, you're going to give that, okay? So 60 minus 360, that's going to be minus 300, okay? And then 300 minus 360, that's going to be minus 60. Now, which of these two answers are inside the range? 60 and minus 60. Okay. So what do we have? We have minus 60 degrees and 60 degrees as our final answer. Okay, but I always prefer to use the method that you're most comfortable with, honestly. There are no extra marks for using a certain method, and no, you don't get penalized for not using a certain method. So can you solve the 8th question? Is that a trigonometry question? Okay, let's do another question. No follow-up part of this, so let's do another one. Let me look for a difficult question. Okay, let's do this one. Okay, let's do this one. Let's see what this is. Acha, there's a... Okay, interesting. Okay. Express tan square theta minus 1 in the form of a sine square theta plus... over tan square theta plus 1 in the form of a sine square theta plus b, where a and b are constants to be found. Okay. So the second you see tan, all you got to do is turn everything in terms of sine and cos. Okay. So tan square theta can be written as sine square theta upon cos square theta minus 1. In the denominator, you will have sine square theta upon cos square theta plus 1. Okay. Now let's take the LCM. In the numerator, the LCM is going to be cos square theta, which means you will have sine square theta minus cos square theta. Okay. In the denominator also, we'll take the LCM, which will also be cos square theta. Okay. Sir, in this previous question, can you substitute a or b instead of cos theta? Yeah, you could do that. You could do that. Okay. You could totally do that. Substitution is something you can always do. Okay. Plus cos square theta. All right. So all I've done is taken the LCM, and yeah, that's it. Okay. Acha. Then what happens is cos square theta and cos square theta gets cancelled, and now this is what we're looking at. We're looking at sine square theta minus cos square theta over sine square theta plus cos square theta, which by the way is equal to what? Which by the way is equal to 1. So might as well not write it. Okay. Or might as well just write it. Just write upon 1. Okay. Okay. Then notice that in the question everything is in terms of sine. So that means that is a sign that we have to change cos to sine as well. So minus 1 minus sine square theta. So we have sine square theta minus 1 plus sine square theta. So what are we looking at? We're looking at 2 sine square theta minus 1 as our final answer. Okay, so there you go. That's your answer. So as always, thoughts on this part before I do the next one? Hello Ibrahim, I'm good. How are you? So this, by the way, is May June 2018, paper 13. Okay, May June 2018, paper 13. Now there's a follow-up part to it. Let's have a look at it and let's solve. Okay. Hence or otherwise, show all necessary workings, solve the equation. Okay. So we already know what tan square theta minus 1 over tan square theta plus 1 is equal to. It's equal to 2 sine square theta minus 1. ठीक है ऐसे है ना 2 sin square theta minus 1. Okay, and what is this equal to now? This is equal to 1 upon 4. So 1 by 1. No, you don't need to do that. Okay, this is not O level. In O level, you were given space for writing down the value of A and the value of B, but here you don't do that. If you do that, it's okay. Nothing to worry about. Okay. So 2 sine square theta is going to be equal to 5 upon 4, which means sine square theta is going to be equal to 5 upon 8. Okay, and then if you take the square root, you have sine theta, which is equal to positive 5 upon 8 inside the square root. Okay, or you have sine theta, which is equal to negative root 5 upon 8. Okay, so let's find out alpha. Let's see what alpha is equal to. Sir, the radian thingy is only... No, it's not just in trigonometry. It's also in circular measure. Okay, so sine inverse fraction square root. So just a minute, sine inverse. Sir, when will you take live classes of mechanics? I will announce. Okay, I haven't started mechanics in my batch yet. We're still doing P1. But when I start, I'll let you know. Okay, so this is what we're looking at. We're looking at alpha to be equal to 52.2 degrees. Okay, so if alpha is equals to 52.2, what does that mean? Now, sine is positive as well as negative. Okay, but the quadrant is only from 0 to minus 90. Okay, that means this is the only angle that we need to find out. So this is 52.2, and here we're going to go in a clockwise direction. And if you go in a clockwise direction, what do we get? We get theta to be equal to minus 52.2 degrees. And there you go. That's your answer. Do you have a video on variation? No, I haven't. I don't have a video on variation, sadly. I'm not too sure. I might, but I'm pretty sure I don't. Okay. All right, let's move on. Part B. Same question, part B. Part B says the diagram shows the graphs of y equals to sine x and 2 cos x for minus pi to pi. The graphs intersect at the points A and B. Find the x coordinate of A. Okay, so we need to find out the point of intersection. How do we do that? How do we find out the point of intersection? Question for you guys. Sir, any thoughts on further mathematics? The thing about further mathematics is that only if you find yourself not at all challenged with regular math, AT maths, and A-level math, then I would suggest you take further math to really challenge yourself. Otherwise, don't. Okay, so sir, do you have a video for... Yeah, I do have a video of O-level AT math, surds and indices. I do. Solve simultaneously, that's correct. Okay, so here's what we're going to do. We are going to equate the two. So from whole P1 topic, which topic? Okay, every topic is important. Okay, every topic is important. Trying to narrow it down to specific topics is like gambling. Okay, sometimes you'll win, sometimes you'll lose. Okay. So yeah, dividing sine x by cos x. So this is what we're looking at, which means we're looking at tan x equal to 2. Now keep in mind, A is going to be, first of all, keep in mind that this is in radian mode. Okay. So let's convert a calculator in radian mode. All right, done. Now tan is positive. Okay, and what is the range? The range is from 0 to it's actually from minus pi to pi. So that means here's 0, here is pi upon 2, and here is pi, and this is minus pi upon 2. So that means this could also be minus pi. Okay. Now tan is positive. That means it could be in the first quadrant or it could be in the third quadrant. Okay. So let's find out alpha by taking tan inverse of 2. So tan inverse of 2 gives us x is equals to 1.11. Okay. Now since it's 1.11, here's what that means. That means it could be 1.11 or it could be pi minus 1.11 with the negative sign. Okay. So since here we can clearly see that the x coordinate has to be less than pi and has to be positive. So that means the only logical solution that we have is 1.11 radian only. Okay, so that means the x coordinate of A is 1.11. Okay, we don't know what the y coordinate is, but yeah, no need to write it like this. We'll just write it. We'll just say x equals to 1.11 and that's it. Sir, can I attend your Zoom classes? Yeah, of course you can. Doesn't matter where you are, you can attend my Zoom classes. Okay, as long as you have an internet connection. But the thing is, I'm not taking any new registrations if you are an A level or AS level student. Okay, I've stopped taking new students. Okay, find the y coordinate of B. Alright, now how do we find out the y coordinate of B? Before I can find out the y coordinate of B, I need to find out what the x coordinate of B is. Okay, so when we were solving this equation, we can see that we are getting two solutions. Now in the first part, we went for the solution that made sense for A. In the second part, we're going to go for the solution that makes sense for the value of B. That means in order to find out the x coordinate of B, we're going to do pi minus 1.11. Okay, so pi minus 1.11, which is 2.03 radian. Okay, so that's this angle right here. But because we have measured it in a clockwise direction, so it's going to be minus 2.03. Okay, and what is this? This is the value of x. What we need to do, however, is find out the y coordinate. So how can we find out the y coordinate? We're going to go back to the question where y is equals to sine x or y is equals to 2 cos x, doesn't matter. So y is equals to sine of the answer. And what are we using as our answer? This is what we are using. Okay, so sine of the answer, let's see what we're looking at. We're looking at y is equals to minus 0.894. Okay, there you go. I just teach online, so I don't teach in a physical sitting anymore. And yeah, there you go. That's the answer. Okay, let's do another question. Let me find out a difficult question to solve. Yeah, let's do this question. Sir, in the playlist, why is part 6 listed before part 5? Okay, I know. Part 6 is listed before 5 because I haven't made that part public yet. That is why. I'll fix that. I haven't made it public yet. I'll fix it. Then I'll make it public. Okay, thank you for pointing that out. Anyway, so just a minute. I fixed it, by the way. Sir, should we? Yeah, go ahead. If you want to watch part 6, go ahead. The only reason why I haven't made it public yet is because the thumbnail is not ready. Okay, let's solve this question. This is from May-June 2019, paper 12. Okay, May-June 2019, paper 12. Okay, let's see what it says. Thank you, Saad, appreciate it. Angle x is such that sine x is equals to a plus b and cos x is equals to a minus b. Show that a square plus b square has a constant value for all values of x. Okay, so what do we need to do? We need to show that a square plus b square has a constant value for all values of x. Yeah, you can join from anywhere in the world, but I don't know what batch you want to join. If you're an O-level or IGCSE student, then yes, you can join. But if you are asking for AS, then I'm afraid I'm not taking new registrations. Okay. So let's start by squaring both sides. Okay. So if I square both sides, let's see what do we get. So we get sine square x, okay, which is equal to a square plus 2ab plus b square. Okay. And then if we square both sides here, what do we get? We get cos square x equal to a square minus 2ab plus b square. Okay. So what do we do? Then we add the two. If we add the two, here's what we notice. First of all, we have sine square x plus cos square x. This becomes 2a square. This gets cancelled. And this becomes 2b square. Now what's sine square x plus cos square x equal to? Sine square x plus cos square x is equals to 1. And what can we take common here? We can take 2 common. So that means we have a square plus b square. And then if you write it nicely, a square plus b square is equals to 1 upon 2. And that's it. That's your answer. Sir, A-level maths, stream B. Sorry to interrupt you, but you missed by common. Okay, Sam, I hope that's how you pronounce it. If you're following on YouTube, then you will see the notification. Okay, you will see the announcement. Okay, that's what I announce. I announce it on YouTube and Instagram. Okay, all the social media pages. Okay, so stay tuned. All right, so we have proved that a square plus b square is always equal to half no matter what the value of x is. Why? Because here we don't have x and it's still equal to 1 upon 2. So that means even with any value of x, things will cancel out and we will just be left with 1 upon 2. Okay. Okay, in the case where tan x is equals to 2, express a in terms of p. Okay, in the case where tan x is equals to 2, express a in terms of p. Now notice that we know sin x to be equal to a plus b and cos x to be equal to a minus b. Now we need to solve tan x, not solve, but tan x equals to 2 is what we're given and we need to express a in terms of p. So what is tan x equal to? Tan x is equals to sin x upon cos x, which is equal to 2. Now what is sin x equal to? Sin x is equals to a plus b. What is cos x equal to? Cos x is equals to a minus b. That's equal to 2. And what do we need to do? We need to express a in terms of p. So that means we are going to cross multiply and make a the subject. So a plus b is equals to 2a minus 2b. Now let's get all the b's on one side, all the a's on one side. So 3b is equals to a, which means a is equals to 3b. Okay, that's a good question. How do we know that we need to add or subtract? Even if you don't, you know what you can do? You can make a the subject. It's going to be sin x. Wait a minute. Hang on. Let me make sure if what I'm saying makes sense. It's going to be sin x minus b. If you make b the subject, that's going to be a minus cos x. 9. So the only way to know that you have to add is through trial and error. Okay. Yeah. Or what you can do is you can find out a square and then you can find out b square and then add the 2, see what you end up with. ये भी कर सकते हैं. ठीक है. Find out a square, find out b square, add the 2, see what you end up with. So are we done with transformation with why isn't it a square? It is a square. Achha. Are we done with functions yet? No, we're not done with functions yet. Anyway, so we're done with the second part. And yeah, that's it. Achha, let me solve a difficult question now. I hope I can find it. Okay, let's do this. So it says here, show that the equation tan x plus cos x over tan x minus cos x equals to k, where k is a constant, can be expressed as. All right. So if you look at the question, share the video on standard. All right, thank you. What we're supposed to bring it equal to has sine square x. Okay, what we have in the question is tan x. So that means immediately we can realize that we have to turn tan x to sin x upon cos x. Okay, so we're going to start with that. So tan x becomes sin x upon cos x plus cos x divided by sin x upon cos x minus cos x. Okay, and what is this equal to? This is equal to k. This question came, yeah, it's a challenging question, and I think it's very recent also. It's October-November 2021. Anyway, so the LCM of the numerator is going to be cos x. That means we're looking at sine x minus plus actually plus cos square x. In the denominator also the LCM is going to be cos x, and we're looking at sine x minus cos square x. Yeah, sine x minus cos square x. Okay. Okay, let's see where we're going with this. So sine cos x and cos x, they get cancelled. All right. And what is this equal to? This is equal to k. So that means we're looking at sine x plus cos square x is equal to, let's cross multiply also, k times of sine x minus cos square x. Okay. Now you can see in the question that they have turned everything to sine x. So that's our hint that we also need to turn everything to sine x or sine square x. So sine x as it is, this is going to be 1 minus sine square x equals to k into sine x as it is, and this is going to be minus 1 minus sine square x. Okay. So this is what we're looking at. Sine x plus 1 minus sine square x is equals to, this becomes sine x minus 1 plus sine square x. Okay, and this is being multiplied by k. Okay. All right, so sine x plus 1 minus sine square x is equal to k sine x minus k plus k sine square x. Okay. Now let's see what the question says. The question says that we have to bring it equal to k plus 1 sine square x into k minus 1 sine x, and okay. So let's have a look and see what we're supposed to bring it equal to. Yeah, this question is lengthy. How many marks is this? A 4-mark question. Okay. So let's get all the sine square x on one side, and let's get all the sine x. In fact, let's get all the terms on one side, and let's do it in such a way so that we have sine square x is positive. Okay. So I'm going to shift all the terms from the left hand side to the right hand side. Okay. So k sine square x plus sine square x plus k sine x minus sine x, okay, minus k minus 1 equal to 0. Okay, so you guys can probably see where we're going with this. Here we're going to take sine square x common. If I do that, we get k plus 1 from the first two terms. Then I'm going to take sine x common. So we get k minus 1. Then we're going to take minus common, just minus. So we get k plus 1 equals to 0. So you can please upload. Yeah, I have an entire playlist on trig. So you will find I think I added the playlist in the description of this video. Let me see. Yeah, so in the description of this video only, you can see a link to the playlist which has all the concepts of trigonometry. It's not complete yet, but it will be complete this week only, inshallah. Okay, so that's it. This is what you were supposed to bring it equal to, and we did that, and we are done. So it was difficult, but we've done it now. Acha, now here's part B. Part B says, hence solve the equation. Okay, so hence solve the equation. We now know what this is equal to. Okay, what is this equal to? This is equal to k. Okay, and k has been replaced by 4. Okay, so what does that mean? That means what we're going to do in our equation is, in the equation that we got earlier, we're going to replace k by 4. Okay, so we're going to replace k by 4. Let's see what happens. So k is equal to what? K is equal to 4. Okay, okay, now if k is equals to 4, let's plug it in, see what do we get. So 4 plus 1 is 5, so that means we're looking at 5 sine square x. Okay, plus 5 minus 1, 4 minus 1 is 3, so plus 3 sine x, minus 4 plus 1 is 5, so minus 5 equals to 0. Walaikum salam. Okay, so this is quite a lengthy question. But anyway, we're almost there. Okay. So we're going to solve this. You can solve it by substitution, or you can do it without substitution. I don't think you can do middle term breaking here. In fact, I know you can't do middle term breaking here. So we're going to do it with the help of the quadratic formula. So sine x is equals to minus b plus minus b square minus 4 into C. Okay. Divided by 2 into A, which means 2 into 5. Okay, so let's simplify this. Achha, here you can use your calculator also and use the quadratic feature of your calculator to get the answer. And I'm going to do just that to save some time. 5, 3 minus 5. Okay, so one value that we're looking at is 0.744. Okay, and the other value that we're looking at is minus 1.344. So clearly this is not possible because sine x can't be greater than 1 and it can't be less than minus 1. Okay. This is what we're going to pursue further. And since sine is positive, that means it could be in the first or the second quadrant. Okay. So first or the second quadrant. And what is this in? This is in degrees. Okay. So let's take sine inverse. Let's take sine inverse. Make sure your calculator is in degree mode, which mine isn't. So just a minute, let me do that. Degree mode, yeah. So sine inverse of 0.744. So we have the value of alpha, it's 48.1. 48.1 here, 48.1 here. Okay, let's find out the value of x. So 48.1 for the first quadrant. ASTC. I'm a little lazy about labelings, but I hope you guys understand what I'm doing here. Okay, 48.1 and then 180 minus answer. So we're looking at 131.9. And there you go. That's your answer. Sir, yeah, so I usually post on my Instagram the topic that I'm streaming a day before or like a couple of hours before. And I also post on YouTube. Okay, so that was a difficult question, and I do encourage you guys to solve the rest of the questions. Let's do one more question where we have to alter the range, okay? And that's going to be the last question of today's class. Because I haven't done any of those, I just realized, so let's do that. Let me find a question where we have to alter the range. Okay, let's do this. So it starts with an identity question. So are you going to keep doing? Yeah, I will be doing AS live streams, of course. Okay, I'll do more, inshallah, close to the exams, but yeah, I will be doing them. Okay. Okay, so prove the identity 1 upon cos x minus tan x is equal to so and so. Okay, and the whole thing square, don't forget that. So first thing we're going to do is we're going to convert everything to sine and cos. Okay, with identity, that's the best tip that I can give you. Convert everything to sine and cos. So sine x upon cos x, and don't forget that there is a whole square. Okay. So what do we have? We have 1 minus sine x upon cos x, and like I said, don't forget that there is a whole square. Okay. Okay, now this is where you have to like practice a lot of identities to know exactly what we're gonna do over here. Why? Let me show you. So in the numerator, we're gonna let 1 minus sine x the whole thing square as it is. In the denominator, we are going to square cos x. So what do we end up with? We end up with cos square x. Okay. Up cos square x is something that can be written as 1 minus sine square x. Okay. Now, this algebraic identity is always hidden in the question. Okay. What algebraic identity are we going to use over here? Okay. So the one I just mentioned, you always have to like make it a point to look for this identity because it's always going to be hidden in the question somewhere. So let me ask you guys, what are we going to do from this point onwards to prove it equal to, prove that this is equal to 1 minus sine x, 1 plus sine x, over 1 plus sine x? Okay. Anyone with the answer? What algebraic identity is it that we're going to use over here? I'll give you guys a hint. Yes, that is correct. Manahil, good job. So in the numerator, we are going to write 1 minus sine x into 1 minus sine x. In the denominator, we're going to use a square minus b square. That means we're going to write it as 1. So basically 1 minus sine square x can be written as 1 square minus sine square x, which means we can write this as a plus b, which means 1 plus sine x into 1 minus sine x. Okay? So that means in the numerator, I can write 1 plus sine x into 1 minus sine x. So this identity is a very tricky identity, algebraic identity, and you'll always find it hidden somewhere. Okay, it's not going to be presented to you, so it'll always be something you will have to really look for. So this is what we end up with: 1 minus sine x into 1 plus sine x. Okay, that's that. Yeah, so that's why I called this question a difficult one. Okay, okay, let's do this now. Now we know that the left hand side is equals to 1 minus sine x. Let me make sure of that. Yeah, 1 minus sine x over 1 plus sine x. Okay. And what is this equal to? This is equal to 1 upon 3. All right, so cross multiply. So we have 3 minus 3 sine x is equal to 1 plus sine x. Acha, also, note one thing, that here the question all of a sudden has used 2x. Okay, so I'm going to have to make some adjustments here. So what we're going to do is we're also going to change it to 2x. Okay, so 1 minus sine x is no more going to be just sine x. It's going to be sine 2x. Okay, just a minute. Let me, yeah, need to restart the app. Okay, yeah. So 1 minus sine 2x over 1 plus sine 2x equals to what? Equals to 1 upon 3. And since the range we have for x and the angle that we have in the question are not equal, the one thing we're going to do, the one thing we need to do is we need to bring them equal. So we're going to multiply everything by 2. 0 remains 0, pi becomes 2 pi. Okay. So now let's cross multiply. So we have 1 minus sine 2x, which is equal to, 3 minus 3 sine 2x, which is equal to 1 plus sine 2x. Okay, cross multiply. Now let's get all the constants on one side and all the sine 2x on one side. 3 minus 1 is going to be 2, which is going to be equal to 4 sine 2x. Okay. The mic has a buzzing sound. Really? Okay. Let me see if I can fix it. Okay, I've decreased the volume slightly. Maybe that will help. Okay, maybe. So this is what we're looking at. We're looking at sine 2x to be equal to 2 upon 4, which means sine 2x is equals to 1 upon 2. Okay. Okay, so sine is positive. Where do we see that? We see that in the first and the second quadrant. So first and the second quadrant. And next thing we need to do is we need to take the sine inverse of 1 divided by 2. So let's do that. Sine inverse of 1 divided by 2. Okay. Let's see what do we get. We get 30 degrees. Achha, this by the way is in radian. So make sure that you convert your calculator in radian mode. Let's do that. See what we're looking at. Sine inverse of 1 upon 2 is 1 upon 6 pi. So 1 upon 6 pi here and 1 upon 6 pi. Now when you solve this equation, remember you're solving for 2x. Okay. So 2x is equals to 1 upon 6 pi. And then the same 2x is equals to 5 upon 6 pi. But in the end, whenever you solve an equation, you're supposed to give the answer for x. Okay, you're supposed to give the answer for the variable that's being used in the question. So what's the variable? The variable is x is x. So x is equals to 1 upon 12 pi. Divide everything by 2 and 5 upon 12 pi. And this is your final answer. Yes, I have uploaded a video on integration already. I did a live stream. I don't know if it was a live stream or a recorded video. But yeah. Yeah, I will be doing more, inshallah. Okay, close to the exams, I will be doing more. Okay? So I will be covering every topic one by one. Don't worry about it. Okay, so I will stop here. And I will, inshallah, see you guys in the next stream. I do ask on my Instagram about what topic is it that I should stream next. I think the next topic I should stream should be functions. Let's see. Okay. So when I post on my Instagram, you guys are very welcome to give me your input. Okay. So yeah, I will stop here. Take care, everyone, and please like the video if you haven't done that yet, and do subscribe to the channel as well. Okay. So yeah, that's it, fellas. See you guys. Take care. Allah Hafiz. Good luck those who have their exams going on.